In the last video, we have finally finished implementing Pattern Manager class and all the other helper classes as well, and the strategies for finding patterns. Now we can finally start implementing the core wave function collapse algorithm. As you might remember, the core algorithm has 3 steps: collapse cell step, propagation step, and analyze state step. So let's go to Unity and create some classes. Okay, let's create core folder, and in it we will create a core solver script. Let's open it up. Let's place it in our namespace and delete the monobehavior inheritance. This class will be running our core algorithm, so 3 steps: collapsing cells, propagation, and analyzing state. So let's create some fields. First of all, we will have pattern manager. We will call it pattern manager. And second of all, we will have output grid, and it will be called output grid. So the output grid class is a class that will store our output grid, so the output of our algorithm. So let's create this class. Let's go back to Unity, create new class, the script output grid, and let's open it. Let's place it in our namespace and delete monobehavior inheritance. So in this class we will create a dictionary of int and hash set of int. So this will be storing the index of our value that we want to solve, of our cell that we want to solve, and a hash set, so the hash set of possible indices that can be solutions for each cell. Let's create the dictionary. We'll call it index possible pattern dictionary. So instead of storing the result in a grid, we will store it in dictionaries because it's much easier to access the values, so hash sets of possible indices in a dictionary than from a grid. Let's create some more fields. It will be width, height, and max number of patterns. So integer width and height. Okay, it will be property, the same for height. Okay, and we need integer, private integer max number of patterns. So max number of patterns variable will be used only for creation of the possible indices lists or hash sets. So we will fill all those hash sets in the dictionary with values from 0 to the max number of patterns. So we will create all the indices of the patterns inside each of the hash sets to indicate that each of the pattern can be a solution for each cell. Okay, let's create a constructor, and let's pass in it width, height, and number of patterns. And let's assign those values. And we will call reset all possibilities method. Okay, let's create a placeholder for this method. Basically, this method will create the dictionary and fill it in with the values from 0 up to the max number of patterns to indicate that each pattern can be a solution for each cell in our dictionary or in our output grid. Okay, so let's create a hash set here of int, call it all possible pattern list. Okay, great. So we'll call all possible pattern list union width and call enumerable. We need to import alt enter using system.link, and we will call dot range 0 to this max number of patterns to list. So basically what it does, it creates a list of all the indices for patterns, all possible indices, and places it in our hash set. Okay, now index. Now let's clear the dictionary. So index possible pattern dictionary, clear. Okay, so it will clear the dictionary out of all the values. And because we want to store all the values, all the cells from our output grid in our dictionary, we want to loop from 0 to width times height. So through every cell in our output grid, and fill it in with and add it into our dictionary, adding the new hash set with all the possible indices for patterns. So let's create a for loop from 0 to height times width, and our index possible pattern dictionary, add for each space a value I, and new hash set int, and pass it all possible pattern list. So we'll create a new hash set that copies the value from our hash set that already contains all the indices for possible patterns. Okay, so we have our output grid ready. Now we need to implement some helper methods that will allow to other classes to access the values inside our dictionary of output grid. Okay, we are missing a brace here. We will implement a method called checkCellExists that return a bool value and takes vector2 int position. And it will check the dictionary if it contains the value. So we will call int index equals get index from coordinates, and we will pass it the position. Let's create this method. So here we will want to return position.x plus width times position.y. So this way we will calculate the index out of the coordinate values. Okay. Next we want to create a method called check if cell is collapsed that also takes vector2 int position and also return a bool value. And it will return get possible value for position, and it will take position as input dot count less or equal to 1. Let's create this method. So here we will check our dictionary if it contains the index at position, and if it does we will return its hash set, and if it doesn't we will return a new empty hash set. So let's call int index equals get index from coordinates and pass to it position, and if index possible pattern dictionary contains key index, return index possible pattern dictionary index, else return new hash set of int. And we need to change the return value for this method to hash set. So in the method above, in check if cell is collapsed, we are checking if the count for our possible solutions is less or equal to 1. If it is, then the cell is collapsed or creates a collision. If it's not, then it is not yet collapsed and it needs to be collapsed. Okay, next method will be checking if our grid is solved. It will return a bool value, check if grid is solved, and it will return if our index possible pattern dict any, we will use link here, x lambda expression x dot value dot count is greater than 1. So basically we are checking if any of the values, so any of the hash sets in our dictionary contains more than one solution that is possible. And if it is false, we will return that the grid is solved. And if it is true, we'll return that the grid is not solved. Next, we need to check if valid position. It will be an internal method that returns bool and takes vector to int position. And we will return my collection extensions that validate coordinates helper method. So we need to import it from using helpers. Call validate coordinates and pass the position.x, position.y, width and height. Next, we need to implement get random cell that returns vector to int. So let's create the method. Find the random index from within the range of our index possible pattern dictionary count and 0. We'll call unity engine dot random dot range and call 0 and index possible pattern dictionary count, and we will return get coordinates for, and it will take the random index. Let's rename this to valid name. Okay, great. Let's create this method. Next, we will need to create a method called setPatternOnPosition that will set the solution for a cell. It will be taking x, y, and pattern index. And we will get the index. And we will create a new vector to int and pass it x and y. So we have our int index. And now we find it in our dictionary and set its value to our new hash set of ints and pass to it the pattern index. So the value that we want to set in this cell. Okay. And last method here will be called getSolvedOutputGrid that will return a jagged array of ints. So here we will convert our dictionary into a jagged array of integers and return it. Let's first initialize a jagged array of integers using my collection extensions. Create jagged array, and we'll pass this height and this width. Okay, great. Next, we need to check if grid is solved, and if it is false, we will return a new jagged array, this time of size 0, 0, to indicate that our output array is empty. And if it isn't, we need to loop through each coordinates, so row, and return value.length or this height for column and this width. And now we will get the index for new vector to int row. Actually this will be column row, and we will return set the return grid. We need to change the name. Row call equals index pattern dictionary index dot first. So we will take the first value from our hash set, but there should be only one, but we are using this to just get the value. Okay, and next we will return the return grid. So this method will be called by the output creator that will create our tile map from the result of our algorithm. Okay, Let's get back to the core solver in the next video, where we will implement the core helper and propagation helper classes.